Hello, today we will be packing the STELLA Q2 wires and using the test codes. First thing you're going to need are your parts. Your 3D printed parts. You got the top housing, the bottom housing, and you have the hold-in clips for your button, your display, your microcontroller, and your battery. Okay? Now we'll set those off to the side here. Okay, here are your various chips you'll need. Okay, this will be your real-time clock, your microcontroller, your display, your button, you have your power switch, you have your battery. Okay, you have a coin battery to insert into the real-time clock. You have your cables. Those are the QWIIC connects. And eventually you'll have your spectral sensor. Alright, let's put it all together and tuck the wires on in. We get our 3D printed pieces here, and they have some supports that we need to basically clean out. And so I like to use a knife here. I'm cleaning these things out, making sure that there's no little dangling chads, if you will. That way we can go ahead and get a nice snug tight fit. But you can say I'm using pliers, I'm using different pieces of 3D printed parts, and shoot, I'm even using a fun little drill bit. But you just break them away and clean out the area, making sure that it's a nice, basically a rectangle there with no dangling pieces. And then you have to do the top housing. And so each of those snap joints, you have got to clean those out. And underneath the TRIAD. Now this is the most sensitive part, so I do suggest something thin. You can use a key or something like that, but I just break those little pieces down there, try and clean them out, and then I try and clean out at the snap joints, okay, and making sure that, again, those are nice and clean. And I like to use a knife for that, so I clean that out pretty well, and it comes off pretty good, and you can see that it's got some nice pliability to those snap joints. Now, I'm going to go ahead and daisy chain my my instrument here, okay, all the electronics. So we put the power switch into the microcontroller. We're going to pop the battery into the power switch, okay, and then we use these QWIIC connects. Now, you always put the shiny side towards the chip, towards the board, okay? So just remember that. Shiny side towards the chip, okay? You'll meet quite a bit of resistance if you don't, and you should not have to meet any kind of real resistance when you're putting these things in, okay? And so I'm going to start daisy chaining. I just put the button onto the microcontroller. Now I'm going to see how it lays down real quick, and I don't like that side of the button, so we're going to change it to the opposite other side of the button. There we go, and it lays a little bit better. I'm not going to pop it in quite yet. I'm still going to continue daisy chaining, so I do the button, and that's going into the clock module. Make sure you put the coin battery, positive side up, into the clock module, and then from the clock module, tuck that in, boom, boom, boom. All right, we're going to put on our spectral sensor. Okay, now you want to make sure that the spectral sensor is aligned, just like so. Okay, with the one sensor facing up. There we go. Pop our cables in there, our QWIIC connects. All right, and then we're going to put on our display. Now, when I lay this thing out inside of the case, I like to put the display in first. I am just checking to make sure that all the lights are green across the board on the back of the chips. If they are, that means it's getting power, so that's good. And we're going to put our display chip in, okay, and hold it snug with the fastener, okay? And then we're going to put in our spectral display, and again, make sure that it's faced this way, just like that, okay? Make sure it's nice and snug and under there. And then we put our clock in and we seal it in. The wires can stick out a bit. I don't mind that. All right. Now you can see I like to put the microcontroller there, and you can see exactly why I put the display in first, because there is a wire right there. So I do that first. Okay. And then we're putting the power switch in or the button. And, I'm debating a little bit as to which order I like to put it in. and the debate's over there. There we go. And so I seem to do this a little different every time I do it, but this is generally a pretty easy, safe way to do it. Make sure to loosen up these cables a little bit because I do like to feed them specifically. So make sure I have a little slack in there. Okay, and then we pop our holder in there. The power switch doesn't get a holster, but the battery does. And you can see I feed that nice little line there from the battery on up. Okay, and there's a nice little channel to do so. Alright, the hardest part is the bulkier white piece, which I like to tuck into that little side over there. Now, with the power lines, the power switch, the switch wires, I like to do some figure eights around those nice pillars. And it is good to note that if anything is above that pillar, that your case will not fit on nicely. Okay, and there is a little bit of basically of give that you can put, especially on the power line. So there, you can pull them a little bit taut. Don't pull them too hard. The QWIIC lines are much more fragile. Okay, and those would be the smaller wires. So don't put too much strain on them. And I don't have fingernails, so this is a little bit more difficult tucking that in, especially where that nice little wrap is on the QWIIC wire. But once you get it in there, it stays nice and snug. Okay. Another note is not to put the wires behind any of the snaps. You'll see that is those snap boards back there are basically just it's a stop for the flexor joints, and so we don't want to put anything behind those. Okay, they actually keep the snapping joints from snapping off. Okay. And so, yeah, there we go. And we get just a little bit of give, and we wrap it around there so it's nice and tight. Everything's looking pretty good. Okay, and we're going to gently pop the lid on there. Okay, I like to push that little snap joint back just a bit and slide it on there. Okay, and there we go. We have our Q2, and I didn't show it there, but I put the signal windows in as well. Okay, now, with our STELLA plugged in via cable to our computer, we're going to open our Mu editor, and we're going to click load and show the serial. Okay, that should be under your CircuitPy there, and then serial up at the top there for your Mu editor. Boom, and there you go. All right, and we're going to check our various different test codes. Okay, and there are quite a few. Okay, and basically they are there to check to make sure that all the bits and pieces are working on the STELLA, that you can record onto the SD card and so on and so forth. So right now you're just seeing down at the serial that I'm getting some 0 responses, and that is because I have my STELLA face down on my couch. Okay, let us do our first test code, which would be the unique identifier. Okay, so you're going to open up your Q2 test codes, and you're going to go to unique identifier, and you're going to drag and drop it into your CircuitPy folder, recording over your other code.py. Okay, and when you do, open up the serial portion of your Mu editor. Hopefully you already have it open, and you should see unique identifier come in on the code. So 3015, boom, we got our unique identifier. The microcontroller is responding the way it should. Okay, now let us test our SD card. Okay, you should have an SD card inside of your Q2 before this happens. Go ahead and drag and drop again to the CircuitPython or CircuitPy folder, okay, and copy over your code.py. And if you have SD card in there, you should get this loop count, and it's recording the date in there. That is not the correct date, but it is recording something inside of there. Okay, now we're going to go to the big one, the clock set. Okay, and so this one, again, if you're going to set your time, this is where you want to go. The time is in UTC, so we go to time.is/UTC, wherever you get your UTC time, and we go ahead and fill in the serial area with that information. Okay, I also like to give it about 5 to 10 seconds lead time when I enter all of this in to make sure that it gives it a little bit of time to save. And excuse me going back and forth, but I'm looking at the time UTC just to make sure that everything is correct. Okay? So, might be a little bit jarring. Alright. We enter all that in, and there it goes. It's shooting out the correct time and date. Alright, so I should be good to go. And that's how you set your time. Now, we're going to test our NeoPixel. And basically what this is just going to do, you drag and drop, again, CircuitPy, and you're going to see a loop down at the bottom here. Okay, and if you take a look, there's the loop count. Alright. Okay, and that's not saying too much to you on the screen, but if you look at your Q2, you should see your LEDs having a lot of fun. And that's it's going through this loop right there. Okay, now we're going to check out the blue LED. Alright, and we're going to do the same thing. We're going to code.py, drag it into our CircuitPython area. Boom, make sure it replaces it. Okay, and you should see, again, another loop. Alright. And you might not see much on the screen, but you will see something on your STELLA. Okay. And so you should see blue LED. Okay. Now, we are going to go to the next step, which is the battery monitor. Okay. And just as before, you are going to go under your battery monitor, drag the code.py into the testing area, and make sure that the battery monitor is operating correctly. Okay, and if you do, you should see a battery percentage in your serial area. Now we're going to test the button. Okay, and we go ahead and, again, go to the button, go to the code.py, replace, hit it in there. Okay, and it should come up with new stuff under serial. And basically, as you start to press the button, hold the button, so on and so forth, it will go ahead and let you know in the serial area. On to the I2C Bus Scan. Okay, we're going to do the same thing. Go to the I2C Bus Scan folder, and we are going to drop it down and drag it over. Drag the code.py over to the CircuitPy files, replace, boom. Okay, once the file is replaced, go down to the serial, and you're going to start to see some addresses found. Those addresses, if you look up in the code file, correspond to the different sensors that you have connected. And if you are missing one, that is a problem. That tells you where to start if you're having problems and everything's connected and you're not seeing it. Now we're going to move on to the TRIAD spectral sensor. Okay, and same as always, you're going to go up there and you're going to drag and drop your code.py into the spectral sensor area. Now, if your spectral sensor is face down, say, and dark, okay, on its underneath the baffle on the Q2, then you're not going to see any spectral response. However, if you lift it up a little bit and give it a few seconds, you should see some, and allow some light into the sensor, you should see those coming in. Lastly, we're going to test the display. Okay, so we go up to our display test, bring the code.py down in the CircuitPy area. Okay, and when we go to the serial, we should see it boot up in a second after it's finished copying. Okay, and then it's going to do a nice loop count. Okay, just like you've seen before, it does a loop count. However, this is going to correspond to the screen. So we'll switch over to the screen of the Q2, and you should see the loop count come up on the screen. There it goes. And we have everything good. Okay, so this STELLA Q2 is functional. So I'll put the main program back on when I'm done and have a completed STELLA Q2. Thank you very much.